right, fellas. The subject is Thermo-Quad for 72. And you're the carburetor experts, so let's get it off the launching pad. Tom, why don't you tell us about the features first? Ed can follow up with the adjustments.
Okay, Tech. Except for the primary metering section, most of what we'll cover also applies to our 71 Thermoquads. Now, as you might expect from the name, the heat-resistant plastic fuel bowl is the basic feature which makes this carburetor different from other types. Besides its basic function, the plastic fuel bowl acts as a heat barrier between the engine and the fuel in the carburetor. The Thermoquad actually runs about 20 degrees cooler than similar all-metal carburetors. Two important advantages are gained by holding carburetor and fuel temperatures down. For one, there's less chance of flooding due to fuel expansion when the engine is turned off, especially in hot weather. And a cooler running carburetor maintains a more constant air-fuel mixture ratio in all operating ranges. Now, to better understand how the plastic fuel bowl does its insulating job, we can consider it as the middle part of a three-layer assembly. Except for linkage and the bowl cover screws, there's essentially no metal-to-metal contact to transfer engine heat to the bowl and bowl cover. As a result, Thermoquad metering calibration is leaner because mixture enrichment is not needed to compensate for fuel expansion power losses. As a result, exhaust emissions are reduced without seriously affecting engine performance.
I like your three-layer approach, Tom. Now, what's the story on the top part, the bowl cover assembly?
Well, the Thermoquad bowl cover assembly includes nearly everything that is in the fuel bowl section of an all-metal carburetor. Float and needle valve assemblies, primary discharge nozzles and venturis, accelerator pump, step-up piston and metering rods, and the secondary jets and nozzles are all part of the cover assembly. Two primary jets and a baffle plate are the only parts located in the fuel bowl. The bowl cover also has conventional air and choke valves. However, unlike other air valve type carburetors, both valves in the Thermoquad are linked to the choke diaphragm. In this case, the choke diaphragm does two jobs. Besides its regular vacuum kick function, the diaphragm also controls the secondary air valve to keep it from opening too quickly and causing flat spots. Here's how it all works. As in other carburetors, engine vacuum moves the diaphragm inward to produce vacuum kick action. However, the Thermoquad diaphragm is linked directly to the secondary air valve by a connecting rod, which also picks up the choke adjusting lever to provide the vacuum kick. Now, while the engine is warming up with the choke on, a tang on the fast idle operating lever lifts the secondary throttle pickup lever. This prevents the secondary throttle valves from opening when the choke is on, even if the pedal is floored. The secondary throttle pickup lever drops and engages when the fast idle linkage moves to off position. The secondary throttle valves can then open in a normal manner. However, as long as these valves are closed, the choke diaphragm holds the secondary air valve closed. Vacuum is routed to the choke diaphragm through a passage which connects to a chamber in the bottom of the throttle body. This chamber is open to manifold vacuum regardless of the throttle valve position. In addition, a bleed passage extends from the diaphragm vacuum passage to a small port in the secondary bore on the choke diaphragm side. This port is closed by the secondary throttle valve and does not affect diaphragm vacuum as long as the valve is closed. When the secondary throttle valves open, manifold vacuum drops abruptly, but the drop in the diaphragm is slowed by restrictions at the bleed port and in the diaphragm vacuum passage. As the vacuum bleeds off, the choke diaphragm acts as a dashpot, preventing the secondary air valve from opening too quickly. As a result, incoming airflow opens the air valve at a rate which provides smooth pickup of secondary fuel nozzle operation.
And to make everything happen when it should, the adjustments have to be right on the nose.
Right, Tech. The interrelated functions of the linkages should make it obvious why the adjustments must be made accurately and in proper sequence. Now, let's move on to the accelerator pump. The Thermo-Quad Accelerator pump cylinder is part of the bowl cover casting and connects to its discharge jet through a short, flexible tube. The intake check valve and seat assembly acts as a closure for the pump cylinder. The intake check valve assembly fits tightly into the bottom of the pump cylinder and can be removed by tapping lightly on the end of the pump plunger shaft. Tap the plunger carefully to prevent damage to the guide lugs on the cover. Now, because less pump output is needed at higher speeds for torque flight models, the pump plunger S-link angles outward so it can move over center. This arrangement reduces plunger travel when the throttle is in the higher speed range. However, full pump output must be available longer for smooth acceleration of manual transmission models, so a two-stage linkage with a pump pickup lever is used. As Ed will point out, this carburetor model requires two separate accelerator pump adjustments.
Before we change the subject, remember that there's a wrong way and a correct way to install the pump plunger S-link. The link will go on either way, but it can hang up over center if the top part of the S points inward instead of out. What's next, Tom?
Next comes the primary metering section, Tech. Thermo-Quad metering rods are yoked to a single step-up piston, which rides in the cylinder in the bowl cover casting. As mentioned earlier, the primary jets are located in the fuel bowl. In addition, the step-up piston has a lift rod which extends down through a passage in the fuel bowl into the throttle body. The bottom end of the rod rides on a lever operated by a cam on the primary throttle valve shaft. In the low and medium speed range, the cam and lever lift the metering rods in proportion to the primary throttle valve opening. This action provides positive mixture control regardless of variations in engine vacuum. However, as the secondary throttle valves open, the step-up piston operates the metering rods in the conventional manner. Vacuum on the piston balances against spring force to position the metering rods and vary the mixture as required by operating conditions.
The length of the piston lift rod is factory adjusted on equipment not available in service. Tampering with a setting will upset performance and emission control, so let it alone. That just about covers the unique features of the Thermoquad, so we're ready to hear from Ed about adjustments.
Ready and waiting, Tech. But first I want to make two important points. One, before you touch any carburetor adjustment, check out all other possible trouble sources. Two, if linkage adjustments are needed, make them in proper sequence so one adjustment does not undo another. Nearly all Thermoquad external adjustments can be made on or off the engine. However, the carburetor must be removed to check or adjust the secondary throttle link. Fast idle speed, curb idle speed, and bowl vent valve settings are adjusted with the carburetor installed. To cover the adjustment story, we'll describe each external setting in the order recommended for a complete checkout. As we go along, I'll point out those adjustments which can be made separately. In general, adjustments which require bending are made in sequence. To check the secondary throttle link adjustment, the choke valve must first be blocked open. This lowers the outer tang on the fast idle operating lever, so the secondary throttle pickup lever moves into position to open the valves. Then, slowly open the primary throttle valves the specified distance from the throttle bore walls. At this point, the secondary valves should just begin to open. For adjustment, bend the throttle link carefully at the angle. The secondary air valve opening adjustment comes next in the sequence, but can be made separately. First, make sure that the valve edges are parallel with the inner walls of the valve opening in the fuel bowl cover. Then, open the air valve against its stop and check for the specified gap between the valve edge and the outer wall of the primary air horn. Bend the notched corner section of the air valve as required to adjust the opening.
That's enough for now, Ed. We're running out of record, so if someone will lend a helping hand, we'll continue with the Thermoquad adjustments.
Now we're ready for the secondary air valve spring tension adjustment, which can also be made separately. First, loosen the hollow adjuster lock plug with the special tool. This releases the spring tension and allows the air valve to drop open. Then, bring the air valve back up with initial spring tension until it contacts its closing stop lightly. Turn the adjustment plug counterclockwise as you test for closing contact by applying repeated opening pressure on the valve. From the initial valve closing position, continue to turn the adjusting plug in the same direction the specified number of turns. At this point, you tighten the hollow lock plug with a special tool to complete the adjustment. The Accelerator pump stroke adjustment procedure is the same on all Thermoquads. Begin with the choke valve wide open and the fast idle cam in off position. Then back off the throttle stop screw so the throttle valves can close completely. Also make sure that the hooked end of the throttle connector rod is in the specified pump arm hole. Apply light force on the throttle lever to hold the primary throttle valves closed. Measure the distance from the top of the plunger shaft to the top of the bowl cover, and if it does not meet specs, bend the throttle connector rod at the angle. Now, on manual transmission carburetors, you continue after the basic pump stroke setting by opening the throttle slowly until the secondary throttle lever begins to move. Again, measure the stroke, and if adjustment is needed, bend the pickup arm on the primary throttle shaft dog. Now we move on to the choke control lever adjustment. For checking on the engine, you first remove the stainless steel choke well so you can use the top surface of the well opening as a reference point for the measurement. When checking with the carburetor off the engine, we set the carburetor on a flat surface which extends the flange line out under the choke lever. This provides the lower reference point needed for the measurement. Now, to check the adjustment in either case, open the throttle slightly to free the fast idle linkage and push on the choke control lever to hold the choke valve closed. Then check the vertical distance between the top of the hole in the lever and the lower reference surface. To adjust, bend the choke connecting rod at the angle. After checking the choke control lever setting, we move to the choke diaphragm. For the choke diaphragm connector rod adjustment and the vacuum kick adjustment which follows, the choke diaphragm stem must be fully retracted by engine vacuum or by vacuum from an external source. Unlike other carburetors, the Thermo-Quad choke diaphragm connector rod adjustment determines the secondary air valve closing gap instead of the vacuum kick opening. We begin the connector rod check with the diaphragm retracted and the air valve in closed position. Check for the specified clearance between the secondary air valve and its closing stop. If adjustment is needed, you bend the choke diaphragm connector rod at the angle. Now, for the next adjustment, if you check the vacuum kick with the carburetor off the engine, first open the throttle so you can move the choke and fast idle linkage to the closed position. Then release the throttle to trap the fast idle cam in the closed position. The choke diaphragm stem, of course, must be fully retracted. The same preliminary procedure can be used on the engine if you use an external vacuum source. But when engine vacuum is used, you back off the fast idle screw until the choke can be closed to the kick position at curb idle. Note the number of turns so you can restore the setting afterward. With the choke diaphragm stem retracted, apply light closing force on the choke control lever to extend the modulating spring and move the choke valve to the kick position. Use a specified drill or gauge to measure the kick opening. You should be able to feel a slight drag when the drill is removed. To open or close the kick setting, bend the tang on the choke adjusting lever. The choke adjusting lever must be supported while the tang is bent, or the choke control lever adjustment may be disturbed. For support, insert a screwdriver blade end in the U-shaped opening between the adjusting lever and the choke countershaft. The next step in our adjustment sequence is the fast idle cam and linkage adjustment. First, you position the fast idle operating lever by putting the fast idle speed adjusting screw on the second step of the cam and against the shoulder of the first step. With light closing force on the choke control lever, the choke valve must open the specified amount, measured between the lower edge of the choke valve and the air horn wall. To adjust the valve opening, you bend the fast idle connector rod at the angle. After the fast idle cam setting comes the choke unloader adjustment. Since the unloader operation permits maximum inlet airflow to overcome flooding, we check the setting with the throttle in the wide open position. Here again we apply light closing force on the choke control lever and measure the amount the choke valve opens. A light drag as the drill or gauge is removed is okay. Bend the unloader tang on the fast idle operating lever to adjust. The secondary throttle pickup lever adjustment wraps up the settings which can be made off the car. Hold the choke control lever in open position and measure the clearance between the pickup lever and its stop. Bend the outer tang on the fast idle operating lever to adjust the clearance. Earlier, we set the fast idle cam position, so now we're ready for the fast idle speed adjustment, which can be made out of sequence. The engine should be warmed up and the basic ignition timing correctly set before you adjust the fast idle speed. With the engine stopped, open the throttle slightly to allow the fast idle cam to engage the speed adjusting screw. Move the choke valve closed so the adjusting screw is positioned on the second step of the cam and against the shoulder of the first step. Start the engine without disturbing the adjusting screw and cam relationship and allow engine speed to settle down. Adjust the screw to get the specified speed and then cycle the fast idle speed screw on and off the cam to double check the adjustment. The next adjustment combines two settings, curb idle speed and the throttle stop screw, otherwise known as the slow curb idle speed screw. Since the tie-in between idle speed and mixture adjustment is generally understood, we'll skip the mixture adjustment details here. Now, you adjust curb idle speed with the engine warmed up and running. Snap the throttle to make sure the curb idle solenoid core is fully extended and adjust the idle screw to get the specified speed. Then, with the engine running at curb idle speed and the solenoid core extended, turn the throttle stop screw in until it just touches its stop. Then back the screw off one full turn to make the final setting. The final external setting is the bowl vent adjustment, which must be made after the curb idle speed setting. First, remove the checking hole plug from the bowl cover and set the throttle at curb idle position with the curb idle solenoid core extended. To measure the vent valve setting, insert a narrow scale into the checking hole to make light contact with the spring-loaded valve. Bend the vent operating lever at the notch if necessary. After checking the valve opening, install a new plug in the cover.
And that covers everything but the float height setting. Tom, why don't you tell us about that and any service hints you have handy?
Okay, Tech. Now, first of all, the floats should be put back in their original locations if they're removed. You check float height with the bowl cover inverted so the floats can rest on their needle valves. Make the measurement from the gasket to the bottom surface of the float at the outer corner. To adjust float height, bend the float lever at the flat section near the lip end. Lift the float when adjusting so the lip on the float lever does not press against the needle valve. To prevent damage, the metering rods should be installed after the carburetor sections are assembled. Position the rod ends inward on the step-up piston yoke and carefully install them as an assembly to prevent bending the rods or yoke ends. Before you install the bowl cover, make sure the O-ring seals are in place in both primary nozzle wells. If either or both seals are left out, fuel will bypass the metering system and result in an over-rich driving mixture. When you install the bowl cover assembly, make sure the float lever pins are in correct position. If a displaced float pin is trapped between the gasket surfaces when the bowl cover screws are tightened, the bowl may crack. An acceleration stumble is often caused by low accelerator pump output. When the system works properly, the pump discharge jet should emit a clear, straight stream from both sides. If you loosen or remove air, choke, or throttle valve screws, secure them after retightening because they can loosen under vibration and drop into the engine. Upset the screw ends with plier pressure or use support so you can peen the screw ends without bending the shafts. That's it, Tech.
Thank you, Tom and Ed, for an interesting and informative session. Thermoquad servicing and adjustment should now be a routine operation for all master technicians. And to wrap it all up, be sure to review the service manual coverage of this new carburetor to get all the details. Read through your reference book to pick up the extras not included in the film. and sit tight for the adjustment review frames that follow the sign-off. So long for now.